This is the game called Chase the Light. The interface for the game is a 8x8 grid of LEDs overlaid on another one. One of them is colored green, the other one's colored blue to be able to distinguish between the player and the computer. The cover on the top I made from a clear styrene, which is sanded down to make it more opaque so it can diffuse the light better. The circuitry on the ground side of the LEDs is two 3 to 8 decoders, each connected to 8 220 ohm resistors. And the circuitry on the positive side is again two 3 to 8 decoders, also with 3 hex inverters. This is because the 3 to 8 decoders that I'm using have a select line low as opposed to the select line high. So the circuitry originally would have been two 3 to 8 decoders, and then the hex inverters would be on the ground side. However, this is switched due to the decoders. For the control, there's a small joystick. It's a two-way potentiometer, so there's a potentiometer in the X direction and a potentiometer in the Y direction. And all of this is connected to the Arduino using only 14 pins to control everything, including the pins to read from the potentiometer. The power for the LEDs is through this external source. It's 4 1.5 volt batteries, and this allows there to be plenty of current to control all of the LEDs, as opposed to the Arduino having to provide all the power from the USB. Right now, what the LEDs are doing is just cycling. This is in the starting phase, as it's waiting for a user input through the serial. So to begin the game, you have to enter a speed that the game is going to be at from 1 to 10. So here, I'll enter the speed and show the serial monitor. This is the serial monitor waiting for the speed to be entered, so the speed I'll just enter 8 right now. And it cycles again using the new speed that's set to give them more of an idea of the speed that the game's going to be. Now it's in the beginning position where the green light is the player and the blue light is the computer. And the player's light can be controlled using this joystick. And the computer's light moves randomly along the grid. When the player's light reaches the computer's light, it does a flash to basically signify that the player caught the computer, and then they both reset to random positions. The computer's movement can be hard to track because it's basically just using random numbers to pick a direction, so you can't easily follow it. It doesn't go in one specific path. When it's randomly reset, that prevents from just specific starting positions where you could always move in one direction to catch the computer. When the player scores, it displays on the serial monitor, displaying the current score and saying that the computer's light was captured, and then it does reset the positions. This is at speed 8. I'll show at speed 2 and also at speed 10 to show the differences between them. This is the cycling at speed 2, and the game should begin in a second. This one, as you can tell, is much slower than speed 8 because the speeds are mapped to a global delay that's passed through all the functions, so it keeps a similar speed for all of them depending on what the serial input is. Except for the flash function, that one is just a specific speed. So again, it flashes every time that the LED is captured, and then the positions reset. And now I'll go to speed 10. Okay, this is speed 10. This one, as you can tell, is much faster, and the computer's LED moves a lot faster. The control LED is also moving a lot faster, which makes it a lot harder to control. One thing that can be seen here is that the control will wrap from the right side to the left side and from the top to the bottom, and that gives it a bigger feel, so you don't feel confined in an 8x8 grid where you have to keep moving the joystick. Once you hit the corner, you have to move back into the rest of the grid. It lets it wrap around so you can go as many times around as you want. And the computer also has this functionality, so it can wrap between the sides so that it makes it a little bit more difficult and it makes it less confined. One thing that can happen is when the positions are reset randomly, they can end up very close to each other, but I don't see this as much of a problem because you won't know where it is right away. So you might start moving in a different direction, and the computer's LED might start moving in a different direction also. So it does provide some space between them. That's about it for my project. Thanks for watching.